Welcome to today's deep dive. I am so glad you are joining us for this one.
Yeah, thanks for having me. This is a topic I'm really passionate about.
Same here. So, for you listening, today we are tackling a really painful and honestly often hidden transition, taking an AI agent from a sleek local demo on your laptop to a robust enterprise-grade production system.
Right. It is the transition that is catching almost everyone off guard right now.
Exactly. And our source material today is an incredibly practical video transcript from the AWS Developers channel. It's titled O5, We Need to Talk About AI Agent Architectures.
It's a great breakdown. Really gets into the weeds of how things actually break in the real world.
It really does. So our mission today is to uncover the most common architectural trap that developers fall into when building these agents, and then, walk through the battle-tested solutions to actually fix it.
Because right now, the industry is heavily optimized for proof of concepts.
Yeah. Okay, let's unpack this. Building an AI agent right now, it's kind of like building a shiny new sports car.
Oh, absolutely.
But all these tutorials, they are basically telling you to take this multi-million-dollar sports car and drive it directly onto the dirt.
Yep. Just straight into the mud.
They completely forget to mention that you need to build paved roads, traffic lights, and guardrails first. So to understand the right way to build those roads, we first have to look at the massive pothole everyone is just driving right into.
And that pothole is the direct client-to-agent architecture.
Right, the anti-pattern.
Exactly. It's what you see in almost every LangGraph or Amazon Bedrock tutorial out there. You basically wire a front-end UI directly to an agent runtime through a single invoke endpoint.
Which, I mean, that works beautifully for a Hello World demo, right? Like if you
Right.
just want to ask your agent for the weather in Miami or what time it
Oh,
is.
sure. For one user under perfect conditions, it's flawless, but in production,
Yeah.
it means the agent effectively becomes your entire backend.
Wow, your entire backend.
Yeah. And that is incredibly dangerous. You are taking a probabilistic, non-deterministic system, the AI, and you're forcing it to handle deterministic routing and client connections.
Which it is not built for.
Not at all. Think about the real-world fallout. Let's say you have a single buggy retry loop on a client's browser.
Oh, yeah.
Yeah. In a standard REST API, that's fine, it handles it, but an LLM endpoint, holding open long polling connections, generating tokens.
That buggy loop is going to cause a massive flood of model invocations.
Exactly. And your LLM costs will just skyrocket instantly. Plus, because your agent is your whole backend, every minor tweak shares the same blast radius.
Right, so if you change one line of code, you are forcing a redeployment of the entire system.
Yep. It's a nightmare for reliability.
It's like letting a brilliant but totally unpredictable chef run an entire restaurant completely alone.
That's a great way to put it.
Like they're cooking the food, taking reservations, running the cash register, bouncing unruly guests at the door. It's chaos.
Absolute chaos.
But wait, I have to push back slightly here. If the agent runtime is fully managed and it scales automatically to handle traffic, isn't that a good thing? I mean, why are we complaining about a system doing exactly what it's built to do?
Well, if we connect this to the bigger picture, infinite scaling without traffic shaping just means infinite unpredictable compute costs. Right. Auto-scaling is just a mechanism. If a front end goes rogue, the runtime scales up and eagerly processes thousands of garbage requests, and you pay for all of them.
So it's an unconstrained liability.
Precisely. Which brings us to the golden rule of modern AI architecture. The agent is not the system.
The agent is not the system.
Right. It is just a capability inside a larger, mostly deterministic system.
Okay, so since we obviously can't let our chaotic chef run the cash register, we need to hire a maitre d' and a security guard.
Exactly. And this brings us to the first architectural iteration, building the front door.
So how do we actually do that?
We add what we call upstream components. You actually keep the exact same agent code, but you put something like Amazon API Gateway or an application load balancer right in front of it.
Got it.
And critically, you protect that gateway with a web application firewall or BROIF.
Okay, so the W is the security guard. What exactly is it doing?
The BROIF handles pure deterministic tasks, things like blocking known bad inputs and rate limiting.
Like blocking an IP address that sends too many requests.
Exactly. Say anyone exceeding 100 requests per 5 minutes gets blocked at the edge. The request never even reaches your compute layer.
Wow, so that neatly solves the whole my agent is my backend problem.
Yeah.
It gives you a place to shape traffic and validate requests before invoking that expensive LLM.
Exactly. You protect the probabilistic engine with predictable logic.
But I have a question about that.
Go ahead.
If we are stacking all these gateways and firewalls in front of the agent, aren't we just adding a ton of latency?
Well, latency is a concern, yes.
Right, because an AI response already takes a few seconds to generate. Is that extra network hop trade-off really worth it for the end user?
Predictability and security always trump raw speed in global distributed systems.
Oh,
Ways.
because an outage is worse than being sad.
Infinitely worse.
Yeah.
Unfiltered traffic can take your whole system offline. But also, practically speaking, the math works out. An API gateway might add, say, 20 or 30 milliseconds.
Oh, that's nothing.
Right. The LLM generation takes 3,000 milliseconds. So the deterministic layer is just a statistical rounding error.
Okay, that makes total sense, but here's where it gets really interesting.
Oh, yeah.
Because we've built this solid front door, right? The API gateway. But if we aren't careful with how we hand out the keys, that front door is entirely useless.
Yes, the authentication vulnerability, this is a huge one.
Right, it's this subtle but critical security flaw. If you use the exact same OAuth token for the API gateway authorizer and the agent runtime, you are in trouble.
Huge trouble, because you've essentially given the client a master key.
So a savvy user could just bypass the API gateway entirely.
Exactly. If a user holds that token and they manage to discover the agent's internal endpoint URL, which leaks all the time in logs or errors, they just call the runtime directly.
Completely skipping all those carefully placed WAF rules and rate limits.
Yep, hammering your LLM directly.
Yeah.
And hoping they just don't find that URL. That is just security through obscurity.
Which isn't security at all. It's like a nightclub. Your ID gets you past the bouncer at the front door. That's the OAuth token.
Right.
But you need a totally separate employee-only key card to get into the VIP vault in the back. Having one shouldn't grant you the other.
That is a perfect analogy. And the fix for this is defense in depth.
So how do we implement that employee key card?
We introduce a very thin AWS Lambda function. It sits right between the API gateway and the agent.
Okay, like an airlock.
Exactly like an airlock.
Yeah.
The system uses the user's OAuth token to authenticate them at the gateway. But then, the Lambda function trades that context for IAM machine-to-machine authentication.
Identity and access management.
Right. So the Lambda uses IAM to connect to the agent. The user's external token literally no longer works on the agent itself.
It dies in the airlock.
Yep. Even if they find the URL, the agent only speaks IAM, it will instantly deny the external token.
Okay, so our architecture is fully secure now. It's cleanly separated.
It is.
But how do we actually add cool, complex features to our app without reverting to our old bad habits?
Like what kind of features?
Like user conversation history. You know that sidebar of previous chats on every AI website?
Ah, yes. The perfect stress test for this architecture.
Because displaying a list of previous chats is purely deterministic,
Right.
but actually using that history to inform an AI's response, that is agentic.
Exactly. You do not need an LLM to render a list of chat titles on a screen.
Right, that would be a huge waste of compute.
So we use the final iteration from our source today. We set up new API endpoints, like a /conversations route, on the API gateway, and those bypass the agent entirely.
Okay, so walk me through how that actually looks for the user. Say I log in and ask, what should I pack for LA?
Okay, so that request hits the gateway, goes through the Lambda airlock, and wakes up the agent.
Right.
While the agent is reasoning about your packing list, it triggers a background tool. It cheaply generates a 3 to 5 word title, like LA vacation packing.
Because the context is already loaded.
Yes. And it takes that metadata, the title, your user ID, and saves it to a fast database, like Amazon DynamoDB.
So it's permanently stored outside the agent.
Exactly.
And then later, when my UI needs to list my past chats, it just runs a simple, cheap database query to DynamoDB.
Yep, 0 agent invocation required.
That is so clean. But what happens when I actually click on that LA vacation packing chat to continue the thread?
Well, the actual chat messages aren't in DynamoDB. Those are stored using Bedrock Agent Core memory.
Okay.
So when you click the chat, the UI sends the session ID, and the agent checkpointer dynamically pulls only that specific thread's history into the context window.
So it only does the heavy lifting when you actively continue that specific conversation.
Exactly. You keep the deterministic UI rendering completely separate from the probabilistic reasoning.
So what does this all mean for someone listening right now? We've focused heavily on Lambda and API Gateway here.
We have, yeah.
Does this architectural philosophy lock you into serverless functions? Or does this separation of concerns apply everywhere?
What's fascinating here is that this is entirely framework agnostic.
Really?
Oh, yeah. The compute doesn't matter at all. The pattern is what matters.
So I could use containers.
Absolutely. You could use an application load balancer with Docker containers on Fargate.
Hmm?
You could use traditional EC2 instances.
Or even AWS step functions if you need complex orchestrated workflows.
Exactly. The foundational principle is always the same. Put a predictable front door between your user and your agent.
It's kind of comforting, honestly. What's old truly is new again.
It really is. You just have to dust off those long understood, hard-earned lessons of traditional systems architecture.
Your agent is a capability, not a backend. That is the core lesson today.
And for you listening, I really encourage you to look at your current AI projects or your proof of concepts and honestly evaluate them.
Take a hard look.
Yeah. Ask yourself, are you accidentally letting the chaos chef run your entire application? Because if you are relying on a single endpoint to do everything, you need to start building that front door today.
Before it costs you 10 grand.
Exactly.
Well, to wrap things up, I want to leave you with a final forward-looking thought to mull over.
Oh, I like these.
All these traditional architectures we talked about today, they work perfectly because current AI agents just sit there. They wait to react to our prompts.
Right, they're basically very advanced answering machines right now.
Exactly. But as we move toward truly autonomous agents, the ones that initiate tasks asynchronously on their own schedule without us prompting them,
The active agents.
yeah, how will our front doors and firewalls need to evolve when the AI is the one knocking from the inside?
That is a very good question. When the sports car wants to go for a drive by itself,
Exactly. How do you safely build a garage for that? Something to think about. Thanks for diving deep with us today, and we'll catch you on the next one.